I welcome you all learners to this video session. So in this video session, we would like to focus a few illustrative problems like find a minimum number in a list and insert a card in a list which is sorted model. And the third one is guess an integer number in a range. So we wanted to predict what our friend guessed the number. And like this, the three problems, we would like to discuss here. See, the first one is, there's a procedure to find the minimum number in the list. So let us consider it is an array. In this array, the numbers are all stored like this. It is some just example I have given this one. So that is in this index 0, 50 is stored and 140 is stored and so on and so forth. Then 4 numbers stored here. Our problem statement is that to find the minimum value in a list, take the first element and compare its value again in the values of the other elements. So how to find the first smallest number? The first number we considered as the smallest number, and this number is compared with the second number, whether the first number is less than the second number or not. If it is less than, then consider this is the smallest number and compared with the third number and proceed. Otherwise, that means the second number is smaller than first number. Now you update the smaller number is the 40. Earlier we updated as 50 and now it is changed to 40. And 40 is compared with the third number. It is smaller. You retain. Otherwise, the third number obviously is smaller. So that the third number you update as the smaller one. And like this, you proceed till the end of this what is called array, and you can find the minimum number. This is the idea behind this demand. So algorithm is given. What I demonstrated, same in this algorithm. With the suitable examples we can see. So let us consider this is the number. As I told you, first assign the first value of the list as the minimum value. So here the first value is 50. The 50 is considered assigned as the minimum number. Then compare this value to the other values starting from the second value. So from the second value onwards, I am comparing with this number. Now I fixed minimum value is 50. The 50 is compared with the second number onwards. The second number I compared. The 50 and this second number is 40. The 40 is smaller. When a value is smaller than the present minimum value is found, it becomes the new minimum. So I assigned that minimum 50. Now I found 40 in the second location is smaller than the minimum. So that the minimum now I have updated. That means from 50 it is updated to 40. Again the same process I am repeating. Now I am going to verify with the third number. The third number is 5. So third number is compared with that is a minimum which is already assigned as a 40. I compared 5 and 40. That is 5 is smaller, so that the 5 is updated as the minimum. Then I compared with what is called the next number, that is a 9. 5 is compared with 9. And obviously that is minimum 5 is smaller. 9 is greater, so that no updation, I am retaining. And again that's a minimum number 5 is compared with the 45, and this iteration also the minimum number 5 is smaller than the 45, so that I retain. And this is the iteration process. The tens of hundreds of data may be in the array. So this is the same process. I am comparing, and if the number is smaller, I update, otherwise I retain, and like this I can find the minimum number in the list. This is a procedure. So you understand the logic and you can demonstrate. This is the first problem. And let us look at the second problem. The second problem is insert a card in a list of the sorted cards. So the idea is that, okay, imagine that we play a card game and we hold certain cards and all the cards are in sorted order. So this is the assumption. So we play a card game and we hold some cards and all the cards are in sorted order. Okay, see here, imagine that these are the cards. Okay, and for understanding purpose I have created array. So that is AF02 is there, AF13 is there. Imagine that these are the cards. Okay, the 2, then 3, then 7, then 8, 10, 13. Like this, all the cards are in sorted array. Okay, at that time, if I wanted to insert a new card, I wanted to find the correct position, then I wanted to insert. This is the problem and this is our demand. Okay, shall we initiate, okay, this algorithm? Shall we execute the algorithm, okay, to achieve how to insert the new card in the proper location? Okay. See here, okay, our demand is that, okay, that number 5, that means card which holds the value 5, we wanted to insert in this cards list. Clear? So that is this index 5 is totally different. Okay, that number, the card which holds a 5, I wanted to insert. What is the procedure? Okay, consider all elements are already sorted. Okay, already sorted in order. Then compare with all elements in the sorted sublist. We will create a sublist and, okay, in this we will shift all the elements in the sorted sublist is greater than the value. Okay, so for example, consider that is a 5. Okay, so the 5 I wanted to insert. For that purpose, I am what is called reviewing, okay, all the cards which is already hold. Okay, 5 is compared with 13. Okay, it is smaller. Then 5 is compared with 10. It is smaller. Then 5 is compared with 8. It is smaller. 5 is compared with 7. It is smaller. Compared with, okay, 3, it is greater. So that now, okay, that means I am executing what is called the step 4. Okay, that the outcome of this step 4 is that system, our algorithm understood that, okay, the number I wanted to insert here, that means after 3, because the 5 is greater than 3 and, okay, that is 5 is less than 7, so that I wanted to insert. Okay, now identified the index, okay, where I wanted to insert A2. Clear? So that is in the position A2, I wanted to insert the key 5. That means the card 5. Understood? Okay. So that is fourth step is executed. Then after that, I wanted to insert. How it is possible to insert? Okay. Now, okay, shift all the elements in the sorted sublist that is greater than the value. That is very important one. Understand? So we are creating a sublist and moving. So these are the sublist. For understanding purpose, the sequence of sublist I created. Okay. So I wanted to create a space here. For this purpose, okay, A5, 13 is stored, that is moved to A6. See here. Okay. So that is moved to A6. 13 is moved to A6. Then next iteration, okay, 10 I wanted to move to A5. Okay. Here 10, the 10 is moved to A5. Similarly, okay, but the 8 wanted to move here, 7 wanted to move here, and like this, okay, 8 moved to A4, then, okay, 7 is moved to A3, okay, so like this, the number 5, okay, is an element which greatest cards numbers wanted to shift one bit higher, one position higher, okay. Now this algorithms shifted and created, okay, that is space here. Clear? Now, okay, so A2 position we reached. Here, we wanted to insert our key. That means I am inserting a card 5. Okay, now see this order. Okay, it is sorted order. So, now we hold the cards which are in the sorted order. Okay, 2, 3, 5, 7, 8, 10, 13. So, this is the procedure. Okay, this is the procedure and the sublist I am referring in this algorithm is these are the sublists. The idea is that okay, that is from the higher numbers, okay, so I am moving to that is a sublist. The purpose is that to wanted to create a space, okay, to store our card. Okay, this is the idea. So with this idea, okay, with this procedure, we can insert a card in a list, and okay, the entire list will be in this sorted order. Okay, so problems demonstrated that idea. I hope you understood this concept. Okay, let us look at the third problem called guessing an integer number in a range. It's a very interesting topic. Reason because the player can guess any number within the range. Then after that, our discussing this algorithm will predict which number our player was guessed. Okay, it is a very simple concept. The prime objective of this idea is randomly generated integer number wanted to identify. So let us consider, okay, that is the number can be guessed between 0 and any number n. Maybe n may be 10, n may be 20 or 200, any number. Then the player has to guess the number. That number is between 0 and n. Then after that, our this discussing algorithm, okay, will predict the number that which is the player's guessed number. If the guessed number of the player is the same as our algorithm's predicted number, then the message will give like this: you have guessed the correct number. Otherwise, if algorithm's guessed number is less than player's guessed number, then we will get output like this: your guess is lower than the number, guess again. If it is greater than, then another message like this: your guess is higher than the number, guess again. Like this, so we can predict the guessed number belong to which range. Based on that, we can predict the correct guessed number within a few iterations. This is a problem statement. When we are discussing that algorithm and a real suitable example, you can understand the logic very comfortably. See here, okay, I told you that is a player. The player will guess the number. Then after that, our system, computer or our algorithm will predict the guessed number. That is the idea. Okay, so the algorithm is self-explanatory. You can easily understand the concept. So that with a suitable example, I would like to explain the idea. Okay, so I told you, okay, before starting this task, needed to fix the range. So according to this diagram, according to this presentation, we will consider, okay, that is number is 1 and 100. That means we wanted to guess the number between 1 and 100. Okay, for understanding purpose, okay, let us consider the player guessed the number 82. Okay, so our program needed to understand, needed to predict what is the guessed number. So our system wanted to declare, okay, the guessed number is 82. Okay, it is the first iteration. As the guessed number is between 1 and 100, okay, the 1 and 100 our algorithm will take and find the mid number of, okay, 1 and 100. So obviously it is 50. Our algorithm first predicted that the guessed number may be 50. This procedure is functioning like this, working like this. So first, okay, the guessed number is 50 by our system, and it is informed to player. Here 50 is too low than guess number. This is the reply. That means that the player didn't, okay, guess the 50, and not only that, the guessed number is higher than our system's predicted number 50. That means 50 is too low. That means that, okay, so the guessed number between 50 and 100 and not in between 1 and 50. So this is the one decision our algorithm will take. Based on this idea, okay, second iteration will start. how the second iteration will start? Similarly, in the first iteration, okay, it will find the mid number between 51 and 100. Reason because already our algorithm predicted that the guessed number between 50 and 100. Okay, so now 51 and 100, it will identify the mid number, obviously 75. Then, okay, our system will display, okay, the guessed number is 75 and the player will tell 75 is too low than the guessed number. Okay, so from this message I understood that, okay, 75 also that is too low than the guessed number. Means that the guessed number between 76 and 100. Okay, with this idea, our algorithm, okay, goes to the third iteration. So it will find the mid number between 76 and the 100 during the third iteration. The mid number is 88. Our system will display 88 is the guessed number. Then the players told, no, okay, 88 also too high than the guessed number. The too high is the message to our algorithm, means that, okay, so this guessed number, that means the player's guessed number is not more than 88. So with this idea, algorithms goes to the next iteration where it's find the mid number between 76 and 87. Okay, 76 and 87. It find the mid number that is 81. Okay, so our system is displayed 81 is the guessed number most probably. Again, okay, player informed that 81 is too low than the guessed number. Okay, so that's the idea. 81 is too low than guessed number. So 81 is not a guessed number. So that our algorithm predicted that the guessed number between 82 and 87, because our algorithm do not know 82 was guessed one. So 82 and 87. So between 82 and 87, again our algorithm will identify a mid number 84. Then it is informing 84. Again, okay, no answer. So 84 is too high. So the system understand that, okay, this number, guessed number between 82 and 84. That means 82 and 83. So 82 and 83, it's identify the mid number. It's not possible. So that it's telling, okay, 82 is the guessed number. Okay, so now, okay, our algorithm identified, that's a predicted, which is the guessed number by the player. So this is a simple technique and a fantastic technique. Only thing is a few iterations required so that this algorithm will predict the guessed number. The main advantage is that any number of large numbers the systems can take. For example, 1 to 100, instead of that, even 1 to 10,000, okay, after identifying first mid number, the system will identify that whether a higher part of what is called 5,000 number or less 5,000 number. Let us consider the random number generated between 1 and 10,000. That's the reason I told, okay, higher side 5,000, lower side 5,000. That means that 50% of unwanted, unrequired, the portion will be removed by this algorithm, so that it is like binary search but with different ideas. So this is the fantastic idea to guess the number by a player. So I hope you understand this algorithm. Okay, watch this video. Till now we discussed 3 problems. One is called finding minimum number in a list, and the second one is insert a card in an appropriate position, and the third one is how to predict, how to find the guessed number. Like these 3 problems discussed. My dear learners, watch the videos, understand the concept and perform well at your university examination to score highest mark. Thank you very much for watching this video. Thank you.